You ask a junior developer to fix a bug. They type the first solution that comes to mind and submit. Sometimes it works. Often it does not. You ask a senior developer the same question. They pause. They think through the problem, consider the edge cases, then write a solution. That is the difference between a regular AI model and a reasoning model. One responds instantly. The other thinks first. Let me show you the difference with one example. You ask both models, what edge cases should I test for a payment checkout flow? The regular model answers in 2 seconds. It gives you a generic list, useful but shallow. The reasoning model pauses. It works through the payment flow. What happens if the card expires mid-session? What if the network drops during confirmation? What if the user double-clicks submit? It thinks the way an experienced tester would. Same question, same AI. Completely different depth of answer. Inside a reasoning model, something called interleaved reasoning happens. The model does not just predict the next word. It alternates between 2 modes. First, it thinks. It generates internal steps, considers different angles, checks its own logic. You sometimes see this as a scratch pad showing its work. Then it responds. It produces a draft answer based on that thinking. Then it thinks again. Did I miss an edge case? Then it refines the response. Think, respond, think again, refine. That back and forth is what makes the answer so much better than what a regular model produces. 2 models you should know right now. OpenAI o3 is built specifically for reasoning. When you give it a complex coding problem or a multi-step logic question, it spends time thinking before answering. Developers use it for architecture decisions, debugging tricky bugs, and writing complex algorithms. Anthropic's Claude with extended thinking does the same, and you can actually see the thinking process. A scratch pad that shows how it works through your problem before responding. Useful when you need to understand why the AI reached a conclusion, not just what it concluded. Both are slower than regular models. Both are significantly better at hard problems. Reasoning models are not for everything. They are slower and more expensive. But for the right tasks, they are the difference between a mediocre answer and the right answer. Use a reasoning model when your question has multiple steps, like debugging a payment bug that only happens on the 3rd retry. When you're making an architecture decision with trade-offs, AWS versus Azure for your specific project. When you're writing test cases for a feature with many edge cases. Use a regular model when you need something fast and simple, drafting an email, summarizing a document, answering a straightforward question. Think of it this way. You would not spend an hour planning how to make a cup of tea, but you would plan carefully before designing a database schema. The skill is knowing which tool to reach for. That judgment is what separates good AI users from great ones.